Data networks, what you need to know. So the most important thing is to think that all smart home systems need some sort of data network. A lot of people ask is, why should I replace my BT Home Hub? It generally works fine. Think of your BT Home Hub or your Sky Hub as a bit like a kitchen fitter. A one-man band who does everything. Your wiring, does the plumbing, puts the cabinets, paints, the whole lot. And he'll probably do an okay job. But is it going to be as good for a higher end kitchen as if you get a separate plasterer? If you get the gods of the trade, the electricians to do the wiring, and a separate plumber to do the plumbing, a separate tiler to do the tiling, it'll probably take a little bit more time to get set up and get working, but the end result will be a much better finish. So let's start out with what your basic network layer looks at. First things first is the modem. This translates the data from your internal network onto the telephone lines that are the external network. So it doesn't matter who your internet comes from, be it BT or Sky or TalkTalk, as long as it's not Virgin Media, that's slightly different. You're going to need a modem. Now, the one that we've got pictured here is a Draytech 130. It's a great little standalone modem. You'll see them all over the place. Okay, so that's what you need to get you started talking to the outside world. Okay, the first thing on the internal network we're going to have is the router. Now the router is the real brains of the operation. So think of this like your foreman on a big site. This is the person who generally knows where everyone's meant to be, who's working where, and also it's the person that will go through to get out onto the wider world, so if you need to get out and get more information. Okay, so that's what the router does. Now most routers will have at least one, if not two, WAN ports. The WAN is the wide area network. So that's the internet. That's the bit we'd connect to the modem, which would go out. You then have LAN ports, local area network. And these are the things that you'll connect to all the devices inside your house, your CCTV, your Xbox, your PlayStation, whatever it is that you've got. Okay. Into the router, if you need more space, you're going to connect a network switch. Okay, so think now of your network switch as kind of like your team leader of a small team. Okay, so they know what's going on in their team, but anything else more complicated than that, they're going to go and have to ask the person above them. This is your router. This is your site foreman. Okay, now a network switch could be quite large. Your small ones that you'll get might be say a 5 or an 8 port, and they'll go up to a 48 port switch. Now there's different types. The general gist of it is either PoE or non-PoE. Now you've probably heard that term banded around all over the place. We'll come to that shortly. And then the other thing is either managed or unmanaged. Now for what we're going to be doing, unmanaged or a smart switch is adequate. You don't really need to be going at this point to the really high-end expensive managed switches. You're just not going to get the best out of it for what you're trying to do. Okay. After that, into the switch, this is where we connect to everything else. But you'll notice at the moment we're not wireless, so you can't pick up your iPad or anything else and use it. This is where we have a wireless access point. The pictured one we have here is a Ruckus. There's a whole mass of manufacturers out there. Ruckus, Unify, Package we use a lot of, things like this. Okay, and they have lots of different capabilities. There's different terminologies, N, AC, then you have different banding types, 2x2s up to 4x4s. It's really a bit of a minefield out there. Go for the best one that you can afford within reason. So don't go buying a top-end Cisco commercial grade one at £800 a piece. You're just not going to see the benefit. You've got to think, your fastest wireless access point might be able to do theoretically 2 gigabits per second to your device. But if your incoming internet is only 35 meg, it doesn't really make any difference at all. So that's the big thing. We will go into a little bit later in this webinar how you actually connect these things up and set them all up from there. Okay. Now you could have a single box solution. That's what your BT Home Hub is, your Sky Hub is. It's got all of those devices all into one. But they can be flaky. If you think about it, they give them out to you for free, and if it goes wrong, invariably you phone them up and say, oh, it's playing up, and after you've rebooted it, they go, oh, okay, we'll just send you another one. So at that point, if you're starting to really hammer them, it might be worth looking at a better single router. So we often point to the Draytechs in this situation, and they're really solid bits of kit. Let's go through how all this equipment connects up if we've got it all individual. So we start with our main BT master socket. That comes out the wall. The newer ones have got 2 sockets on it, one for the phone line and one for the internet. So we're going to connect to the internet. that'll go into our modem. The modem has got 2 ports on it, the line and the LAN and the WAN port. That will then go to our router's WAN port. From the router, any of those LAN ports are now internal. You can plug a piece of equipment straight into that. But if you need more devices, say you've got cameras and some wireless access points and lots of bits of kit, you plug in a network switch, and from the network switch you'll go into all your other bits of equipment, such as your wireless access points. Okay, and it's really that simple. The thing to remember here is make sure you've got the right terminology. So if you're looking for extra bits, what do you actually need to add in? Now, all networks at this particular level are going to have one modem and one router. Okay, if you have multiple routers, something's probably gone wrong somewhere, okay? Unless you've got a very advanced network, at which point you're probably not watching this webinar. If you need extra ports, so if you've got 4 things plugged in already, but actually you now need to add in an extra 2 or 3 things, it's a switch, okay? And you can have multiple switches. You could have lots of 4 or 5 port ones, but really you're much better to look at the whole project and go, okay, I think I'm going to need about 15 ports, so buy one 24 port switch. It'll just work out a lot better and a lot simpler going forward. Okay. Once you've got it all together, it'll look something a little bit like this. This is a basic one in a rack with some Control 4 equipment, and you see here there's actually 2 network switches. So this is where we came to the PoE. One of these is PoE and one is non-PoE. So one of them connects the equipment in the rack and to televisions and Xboxes that don't need power, and the other one does all the CCTV, does all the touch screens and things like that. So what is PoE? Power over Ethernet. It's a single cable, a Cat6 cable or a Cat5e if you're stuck, that'll take both power and data. Now, you're not going to run your house off it. It'll deliver in standard mode about 15 watts of power, and PoE Plus will do 30 watts. Now that is actually plenty for the vast majority of things. So we are running all sorts of equipment over this, so video transmission devices, like I said, cameras, wireless access points, and we never have a problem with the power. You do need to look at the switch that you're buying though. So even though it's say an 8-port switch and it's got PoE on all 8 ports, you'll have a budget of its power. Okay, so let's say it has a power budget of 60 watts. So obviously over all 8 ports that can't possibly do 15 watts per port. Now if your devices are only 5 watts each, that'll probably be okay, but they won't be, especially cameras. And this is a problem that we see quite regularly with people who phone us up and say, well, the cameras work fine during the day and at night one will drop in or out. And what it is, the infrared lights have come on the cameras, and therefore the power requirement has gone up, the switch can't deliver the power, and so it will turn that port off and it'll carry on happening. So just need to bear that in mind. If you're going to power things via PoE, make sure you're budgeting for it. Not dissimilar to how you'd look at specifying a fuse board and making sure you've got enough power, enough of the right fuses for that particular circuit in the house. Okay, so let's start with our first example. We want to add an extra wireless access point. If it was me and I was just doing a single standalone house, customers just phoned me up and said the Wi-Fi is really bad in this new extension, what would I do? Okay, go and buy a Unify wireless access point. There's loads of places you can get them from, Broadband Buyer, Foregone, loads of places online, even Amazon if you're stuck. And they arrive as a little kit. In the kit you've got the wireless access point, which is a little white disc, and then you'll have a passive PoE adapter. So what we're going to do is run your Cat6 cable from roughly wherever your router is over to wherever you need your Wi-Fi to be. Take the short cable out of your existing router and plug it in to the PoE injector, and then take the long cable that you've run to your new location out of the PoE injector on the side that says PoE and run it over to your wireless access point. You then put a bit of power into the injector and away you go. Hopefully at this point your access point will start flashing. You can find it on your app, and it's a Unify app that we can use, really simple, and set it up and away you go. You look amazing, you charge the customer a fortune and everyone's happy. No, you charge them a very reliable, reasonable rate for a pre-agreed piece of work. Okay, it's nice and simple. Now, how about if you want wireless in your shed? Now you've got a couple of different ways of doing it. If you can, the easiest is to just run a cable. You just run a long cable, duct grade, or you can get steel wide armoured if you really need to, run down to your shed and do the same principle you've done inside the house. If you can't do that, you can put a wireless transmitter on the outside of the house and then a receiver on the shed, and that'll link the two. And what that'll do is in essence create a wireless bridge. Now you can't just put anything into that. You're then going to need a little wireless access point inside the house, but it'll still work. So it's a really nifty way of adding a few extra things. Okay, this is a tricky one. How many wireless access points do I need? Now, you are all, I'm sure, excellent electricians, and you would know, walking into a house, roughly how many circuits it's going to have and the rough power demands it's going to be on it. But you'd still do your calculations to make sure those numbers were correct. And similar with wireless access points. We would walk into a house, look at the construction of it, and decide and the rough number of users and make an educated estimate. So, if it's a nice modern house, which has probably got timber walls and it's quite an open plan, it won't be that many. If you're in some 17th century barn, which has got 3-foot thick walls, you're probably going to need a wireless access point in every room. Now, the easiest way of checking is to get a wireless access point, place it in each room and walk around and do what we call a wireless survey. It'll look something like this, and what it will show you is the amount of dB loss, dB is the power level, in each area, and from that you can calculate out how many wireless access points you need. That's basically it. You can get companies in to come and do this for you, but it's not that complicated. You spend a few minutes, maybe an hour or so, just going around, having a good look, figuring out your cable runs, and go from there. Okay, next up, IP addresses. What is an IP address? Your IP address, in essence, is like your computer's phone number. So it's what identifies your computer on your network. Now, this is where it gets a little bit interesting. Let's break down the individual parts of what an IP address is. So like I said, the IP address is that device's address on the internal network. And two devices on the same network should never have the same IP address. If they do, the traffic is not going to know where to go. So for example, we go back to our building site analogy. That router goes, okay, you're number 1 and you're number 2, and it sends the 2 teams of electricians to site 1. What's going to happen? Probably going to be a bit of a clash. You'd send one to site 1 and one to site 2. Okay, that's how that works. Subnet masks. This is how many different addresses there can be on a network. The gateway. This is the direction the network traffic is going to go to try and get out onto the internet. It's normally the router. 192.168.1.1 is the common one. BT like to mess with all of us, and there is .254 just to screw with our head. Okay, and the one other piece of information that we generally need is the DNS. That's the domain name service. The domain name service is when even the router doesn't know where it is, how everything finds out where it's going to be. So if we type in google.com, our computer knows which server to go to get that information, and that's because it's looked it up. So the DNS is basically a massive telephone directory run, would you believe, by the US military. That's a different matter, and it works in a hierarchical way. So if you type in google.com, the first thing that's going to happen is your computer's going to say, well, am I google.com? It's probably not, I'm afraid. Then it'll ask the switch it's connected to, is anyone else here google.com? No, it's not. Then it'll go to the router. Your router won't know, so it will then go up to your ISP. So it'll go out to BT or Virgin or whoever it is, and it will then go forward from there. Without going into crazy amounts of information, that's basically DNS. When you're asked to put in DNS addresses, my humble opinion, use Google's address. So theirs is 8.8.8.8, and their alternate one is 8.8.4.4. The reason we use that is it looks up very quickly, and they keep their servers really up to date. There are other ones out there you can use. 1.1.1.1 is very good, but generally we use Google's and it works really well. So let's have a quick look at some frequent problems that you may well come across. So devices in a different IP range, and this happens generally with new equipment that comes out the box. So you've got your normal BT network at home, fine, you've plugged into it, it's all good. You get a new device, let's say it's a camera, and you plug it in and it powers up, but you can't find it on the network, it's not showing up. Now there's every chance that it's on a different subnet. So your BT range is 192.168.1.x, and this camera could well be on 192.168.0.x. Okay, so you just need to change your computer's IP address to be something in the other range. Okay, well, plenty of videos out there to show you how to do it, but we may well cover that in another time. DNS, again, like we said, use Google's DNS 8.8.8.8 and 8.8.4.4. Okay, if you've tried all these things and you still can't see what's going on, you can't talk to it, check the cables. If you start going down this route a lot more, you'll do what's called a Cisco Certified Network Engineer, a CCNA. And the number one thing they'll teach you is what they call the physical layer. Basically, it's the cables. Is everything plugged in properly? Check the cables. Get yourself a cheap network tester. It's like 20 quid off eBay, or Screwfix even sell them. And check. Do all the lights light up in the correct order? Has everything got power to it? That's always the one. Okay, that's it for this week, ladies and gentlemen, and boys and girls, and those who have yet to decide. And hopefully we'll now go into the Q&A. Thank you.